Hi everyone, this is Miss Afric here, and today we're going to be doing our 8.6 video notes. We're going to continue talking about solving equations, and specifically, last video talked about solving exponential equations, well now we're going to move into solving logarithmic equations. Okay, so everyone should have this goal written down. The goal for today's video is going to be to solve an equation that contains logarithms by exponentiating both sides. Now I know it kind of looks like we made up that word, but that is a word. When we say by exponentiating both sides, that just means we're going to raise both sides to an exponent. And you'll see what we mean once we start these problems. That's what exponentiate means. Okay, in the last video we talked about how, you don't have to write this down, but just to see an example, if we had something like 5 to the x equals 12. In order to get rid of this base 5, we had to create a log base 5. And of course, whatever you do to one side, you have to do to the other side. And that's how we would then get rid of the base 5 to be left with just x. Well, here we're going to be doing kind of the opposite of that, because we are going to be given a logarithm, and we're going to use a base to get rid of the logarithm. So let's take a look at example 1a. Example 1a says solving a logarithmic equation, and then it says to solve log base 3 of x plus 3 equals log base 3 of 8x plus 17. So again, before, right, I'm just going to write it down real quick again, a base 5 to an x. To get rid of that base 5, we did log base 5. Well, to get rid of a log base 3, right here, we're going to have a base 3, which means we are going to exponentiate both sides so that there is a base 3 on both sides. Because this right here is a 3 and this one's a 3, that's how we know that raising both sides to an exponent of 3 is going to get rid of that log. So what it's going to look like is, instead of log base 3 of x plus 3, I'm going to exponentiate it, so it's going to be 3 to the log base 3 of x plus 3. And whatever I do to one side, I have to do to the other side. So 3 to the log base 3 of 8x plus 17. Alright, so I made each one of these sides the exponent of 3. The reason that that's helpful is because, just like in the last video, 3 to the log base 3, well, we know that those will cancel each other out, so we're just going to be left with x plus 3. Similarly, on the other side, base 3 and a log base 3 get rid of each other, so I'm just going to be left with 8x plus 17. And now this is just a simple equation to solve. Remember, if we have multiple x expressions, we got to get them together. So I'm going to go ahead and subtract x from both sides. Gets rid of it over here. And then I'm going to be left with, let's write it over here, a 3 on left side. 8x minus 1x is 7x plus 17. Then let's subtract 17 from both sides. 3 minus 17 is negative 14 equals 7x. And then we just got to divide by 7. And x is going to equal negative 2. Alright, so it's as easy as that. When we've got a logarithm on both sides, we have to have that same base so that when we exponentiate both sides, we are using the same base. Because as always, whatever you do to one side, you have to do to the other. Can't change that up. Alright, let's take a look at example number 2. Example number 2 says exponentiating each side. So these problems are a little different because there's only one logarithm. And when there's only one logarithm, it's going to be extremely important that you really understand how we get rid of that logarithm. So to get rid of a log base 5, I need to put a base 5 out there, and then this will become the exponent, the log base 5 of negative 3x plus 1. But whatever I do to one side, I have to do to the other, so I need a base 5 on the other side as well. So that what this is going to look like is 5 to the log base 5 of negative 3x plus 1 equals 5 to the second. So then over here, 5 log base 5, those are gone. So we're just left with negative 3x plus 1. And then be careful here, we no longer have a logarithm that we're getting rid of, so 5 to the second, we're just going to simplify that, and that's 25. And now, once again, this becomes an easier problem to solve. Subtract 1 from both sides, negative 3x equals 24, and then we just got to divide both sides by negative 3 to get x equals negative 8. And there's our answer. Alright, so again, the way we get rid of a log base 5 is to exponentiate it to the base 5. So it becomes the exponent of a 5. That way we can cancel those out. Alright. Letter B is somewhat similar. Let's go ahead and have you guys try that one on your own. See if the earlier steps that I did in part A make sense. I'll do the problem as well. Pause the video so that when you unpause it, you can check to see if you got the correct answer. Alright, so go ahead and pause. Right now. Pause. Pause the video. You better have paused it. And we're back. Hopefully you paused it so you could actually try this one, see if it makes sense. Again, the goal of these problems when there's one logarithm in the entire problem is you got to figure out what your base has to be, and it's all relying on what the base is of your logarithm. So since I have a log base 8, I know I want to make my base 8 to cancel that out. So it becomes 8 to the log base 8 of x minus 4, and whatever I do to one side, I have to do to the other. So the other side becomes 8 to the 2. Simplify it down and solve for x. If you're ever not sure, remember you can plug these answers back in and check to make sure they work. That's always a possibility, and actually in a little bit we'll talk about how it's kind of a necessity. Alright, flip the page over. Let's try a few more. Example 3 says checking for extraneous solutions. Hey, that's what we were just talking about. This shouldn't sound too unfamiliar. We talked about this in Chapter 7, how there are certain types of problems that you could solve for x, and then the answer you get might not end up working. So you always want to check for extraneous solutions, and all you have to do that is substitute your solution back into the problem. And check to see if you get a true statement. Now, one thing that you do have to be aware of when we're checking for extraneous solutions is remember that this value inside the logarithm, alright, technically it's known as the power, that value cannot be negative. Because if it was negative, it wouldn't work. It wouldn't be real. There's no way to get that to be negative. So if you ever get a solution that makes the number inside a logarithm negative, you know that it's going to be extraneous. So something to keep an eye out for. Alright, let's try this problem. So this problem's again a little different because although there are two logarithms in the problem, they're both on the same side and we're adding them. We're not going to be able to exponentiate both sides if we've got this addition thing there. It's going to kind of mess things up. So what I suggest always doing with these types of problems is combining your logarithms into, let's say, combining your logs into just a single logarithm using our properties. So here I have log of 5x plus log of x minus 1. Don't forget that even though we don't see a base there, what's our base when there is none there? Hopefully you all answered with a 10. So there's really a little log base 10 down there, just so you can see it. Alright, and remember that when we are adding two separate logarithms, our exponent property says that we can combine it into one logarithm, log base 10, by multiplying the powers inside. So 5x times x minus 1. And that's how we can combine it into one logarithm. So now if I simplify inside there, log base 10, I'm just going to keep that base 10 there so you can see it and remember that it's there. 5x times x minus 1, let's just distribute that to get 5x squared minus 5x equals 2. Now we're back to a normal problem similar to the ones we did before. I should be able to recognize that there is a base 10 here, which means in order to get rid of a log base 10, I need to raise both sides to an exponent of 10. So it becomes 10 to the log base 10 of 5x squared minus 5x. And whatever you do to one side, you have to do to the other. So 10 to the second. Alright, over here, 10 and log base 10, those should cancel out. So we've got 5x squared minus 5x left on the left side. And that's going to equal 10 squared, which is 100. And remember, whenever you have a quadratic like here, in order to solve it, you've got to get it to equal 0 and then factor it so that we can solve it. That's always the easiest way to solve quadratics. So I'm going to subtract that 100 over to the other side. 5x squared minus 5x minus 100 equals 0. Then hopefully we can all recognize that there is a GCF of 5 in this problem. That's going to make it a lot easier to factor. Alright, so I need, since this is just a 1x squared, I just need something that adds to -1 and multiplies to -20. Feel free to pause and try it on your own, but I'm just going to write the answer right here. X minus 5 and x plus 4. So that's going to give us our solutions. I'm just going to bleed down a little bit into the second problem. Of x minus 5 equals 0, that gives us x equals 5. And x plus 4 equals 0 gives us x equals -4. And here are our two solutions. But don't forget, remember, we just said it at the beginning. We have to check for extraneous solutions. So let's go ahead and quickly plug these back in, see what ends up happening. Alright, when I plug 5 back in here, let's do it in this little area that I kind of have open. There we go. If I plug x equals 5 back in, I've got a log of 25 plus, scooch this over, a log of 4. And I'm checking, does it equal 2? Well, let's check in the old trusty calculator. Log of 25 plus log of 4. Guess it equals 2, so that one looks good. Let's try the -4. So then I've got log of -20 plus log of -5. Does that equal 2? Well, hold on a minute. Remember what we just talked about. These numbers right here, oops, right here, can't be negative. And if they ever are, you know that right away that's not a solution. So I can cross out x equals -4. That's not going to work. So my only solution here is going to be x equals 5. Whew, that was a long problem. Let's see, we've got 2 more problems. I want you to try letter B on your own. And then I'll get you started on letter C, and let's see how far we can get through it. Okay, try letter B on your own, though. Check for extraneous solutions. Don't forget to do that problem. Who knows, you might have a quiz on it in class. Hate to miss out on those points. Alright, letter C is pretty similar. We've got 2 different logarithms. Remember, ln, that's just log base e, so don't get freaked out. Alright, you can feel free to rewrite it as log base e if it makes you feel more comfortable. I'm just going to leave it as natural log ln because I know that there's a base e in there. And just like before, I want to combine these using my properties. So if I'm subtracting, that means I need to divide those powers. So x minus 1 divided by x plus 1 equals the natural log of x plus 5. Now this is similar to the first type of problem we did because there's a natural log on both sides. Again, natural log is just log base e. So if there's a base e in here, that means in order to get rid of it, I need to make my base down here e. So it becomes e to the natural log of x minus 1 divided by x plus 1 equals e to the natural log of x plus 5. And this e and natural log, both of them end up canceling out. So we've got x minus 1 divided by x plus 1 equals x plus 5. Alright, now this is going to turn into a quadratic also. You're going to have to multiply both sides by that x plus 1. So feel free to try and finish this problem off. Otherwise, we'll finish it in class together. If there's anything you didn't understand, go back and watch it. Hope you had as fun a time as I did. See ya.